Let's practice writing complete factor lists using some prime factorizations together. Now, generally to make a complete factor list, it's helpful to have a prime factorization. So I'm going to go ahead and take this number 10 and think of two numbers that multiply to get 10. I'm going to say 2 and 5. Now, 2 and 5 happen to be prime numbers already, so this is a short prime factorization tree. So if we're going to go ahead and say, what is 10 equal to? Well, 10, its prime factorization is just going to be 2 times 5. Right? It's a very short prime factorization. Now we can go ahead and use this to make a complete factor list. Now, 10 has the factors of 1 and 10 to begin with, right? 1 times 10 is 10. And then we're going to see that we do see a 2 on this list, so 2 times 5 is equal to 10. So this one's very short, but we have a factor list of 2 and 5 along with that 1 and 10. So in this case, these are going to be all the factors. For number 2, let's take a look at the number 12 now. So for the number 12, let's see what that breaks into. 12 is going to break into maybe 4 times 3. Now, if we take a look at these numbers, you can see that this 3 is prime. This 4 is composite, so we can break that down into 2 times 2. And we go ahead and circle these 2's. These are all prime numbers now, right? So 12, its prime factorization, we can go ahead and say is going to be the product of 2, 2, and 3. So let's see, we have a factor list for 12. We're going to start with 1 and 12. Always start with 1 and the number itself. Then we can see that there is a 2 here. Now 2 multiplied by the rest of these numbers, so 2 times 3 is 6. That means 2 times 6 is going to equal 12. 2 more factors. Next, we think of the number 3. Here's number 3, and then these two numbers make 4. So 3 times 4 is going to be 12. These are going to be all the factors of 12. There are 6 of them. 12 has 6 factors. For number 3, we have the number 15. So let's take this number 15 and see what prime factors we have. Well, it looks like we just have 3 times 5 is 15. And this one's very short because 3 is prime and also 5 is prime. So if we write the prime factorization for 15, it's actually quite short. It's just this 3 multiplied by 5. So what are all the factors for 15? Well, we're going to start with saying it's going to be 1 times 15. That's going to be 15. And then we can see on this list we have no 2's, but we do have a 3, so it's going to be 3 times 5. So again, this one's going to be a very short list. 3 times 5 is 15. So 15 has these 4 factors. For number 4, what's going to go on here? Well, for the number 19, 19 is actually a prime number. So if we try to make a tree or a prime factorization tree, we actually can't. We're actually just stuck with the number 19 since it's prime. So if you're wondering how to write the prime factorization of a prime number, you just go ahead and write that number itself. It's just going to be 19. And based on that, we could take a look. What are all the factors of 19? You really should just have 1 and 19. Okay, so remember, by definition, prime numbers have exactly 2 factors. So that makes sense. We only have 2 factors here. For number 5, let's take a look at another one. We have the number 24. So let's take this number 24 and see what we can break it into. I'm thinking maybe 6 times 4 to start. Now 6 is composite. It breaks into 3 times 2. And 4 is also composite. It breaks into 2 times 2. All right, so let's see. This 3 is prime. This 2 is also prime. This 2 is prime, and this 2 is prime. So the prime factorization for 24 is going to be the product of 2 and 2 and 2 and 3. So let's go ahead and use this prime factorization and write the factors of 24. Without thinking too much, try to just write 1 and 24. Those are going to be 2 of the factors. If you take a look here, we do see a 2 on the list, so it's going to be 2 multiplied by what? Well, 2 times 2 is 4, times this 3 is 12, so 2 times this 12 is going to be 24. But 2 times 12. Do we see a 3 on the list? Yes, we see a 3 right here. So 3 times what? Well, 2 times 2 is 4, times 2 is 8. So we're seeing here it's going to be 3 multiplied by 8. Now, do we see a 4 on the list? Well, yeah, these two 2's make 4, and then this 2 and 3 makes 6. So 4 times 6 is going to be 24. All right, and there's no 5 on the list, and there's no more numbers between 4 and 6, so this is our complete factor list for 24. It has 8 factors. For number 6, we have the number 36 here. Let's take this 36 and see if we can write its prime factorization. So I think a common one to start with here is going to be 6 times 6, and then 6 will break into 3 times 2, And this 6 can also break into 3 times 2. All right, now 3 is definitely prime, 2 is prime. So let's go ahead and circle all these prime numbers at the bottom here. And let's see, 36 is going to be equal to this 2 times 2 times 3 times 3. That's its prime factorization. So what about all the factors? Well, for 36, let's start with 1 times 36. There we go. And do we see a 2 on the list? Yep, we see a 2 right here. 2 times what is 36? Well, 2 times 3 is 6, and 6 times this 3 is 18. So that means it's going to be 2 multiplied by 18. What about 3? Well, we do see a 3 here. So 3 times what is 36? Well, 2 times 2 is 4, and 4 times 3 is 12. So 3 times 12 must be 36. It's going to be 3 times 12. What about 4? Well, these two 2's make 4, and then these two 3's make 9. So that means that 4 times 9 is going to be 36. What about 5? We don't see a 5 on here. It's prime. What about 6? 2 and 3 over here make 6. And then this 2 and this 3 make 6. So that must mean that 6 times 6 is 36. And hopefully that makes sense because we had that in our prime factorization tree. Now, while it looks like 36 does have 10 factors, keep in mind that the 6 times 6 is actually repetitive, so you can actually get rid of one of these 6's because there's really only 9 factors for 36. So all perfect squares will have an odd number of factors instead of an even number. All right, number 7, we have this number 25. Let's go ahead and see if we can break that down. Go ahead and make a tree here. So we're going to have 5 times 5 is 25. Very short tree here, okay, very small because we just have these prime numbers here. Now 25's prime factorization is very straightforward. It's just 5 times 5, right? Not long at all. Now what are all of 25's factors? Well, it should be a relatively short list. Let's start with 1 and 25. And we can see here that there's no 2, there's no 3, there's no 4. We just have 5 times 5. Just like earlier with the last number, because it was a perfect square, you can ignore one of these 5's as one of the factors. So there's technically only 3 factors for 25. Don't count the 5 twice. For number 8, we have the number 54. So take this number 54, if we break this down, we're going to end up with, let's see, I'm going to start with 6 times 9. Feel free to start with something different. 6 can break into 3 times 2, and this 9 can break into 3 times 3. All right, so let's go ahead and just circle these primes, 3, 2, 3, and 3. So the prime factorization for 54 is going to be 2 times 3 times 3 times 3. Let's write a factor list here for 54. Start with that 1 and 54. There we go. Do we see a 2? Yep, here's a 2. 2 times what? Well, 3 times 3 is 9, and 9 times 3 is 27. So it's 2 times 27. 2 times 27. Cool. Is there a 3? Well, for sure, there's a 3 here. So 3 times what is 54? Well, 2 times 3 is 6. 6 times 3 is 18. So that means that 3 times 18 is going to be 54. 3 times 18. Is there a 4? I don't think so, because you need 2 2's to make 4. 5, there's no 5 here. What about 6? Well, here is 2 times 3. That gets you 6. 3 times 3 is 9. So that means 6 times 9. And that was in our tree, so hopefully that makes sense. The only numbers between 6 and 9 are 7 and 8. And you can't get an 8, and you don't have a 7 in that prime factorization, so this is going to be our complete factor list. 54 has 8 factors. All right, here is number 9. For number 9, we have the number 30. So let's take this number 30, and let's go ahead and make a prime factorization tree first. I'm going to start with maybe 10 times 3. I know this 3 is prime, so I'm going to circle it. And then this 10 can break down into a 2 times 5. All right, so it looks like we have 3 of these prime factors here. So our prime factorization is going to be 2 times 3 times 5. All right, so let's write a complete factor list now. So start with 1 and 30. Now we see a 2 here, so 2 times what? 3 times 5 is 15. So we can say 2 times 15. What about 3? Well, here's 3. That's good. It's on the list. That means 2 times 5 is 10. So it's going to be 3 times 10. There's no 4. There's 5. Yeah, I think we do have a 5 here. So here's 5. And then 2 times 3 is 6. So 5 times 6 must be 30. 5 and 6. Cool. I think that's going to be our complete list here. 30 has 8 factors. For number 10, we have the number 60. So let's take that number 60 and break that down. I'm going to start with 6 times 10. And then for 6, I'm going to break that into 2 times 3. And for 10, I'm going to break that into 5 times 2. So here's a prime, here's another prime, a third prime, and a fourth prime factor. So we can go ahead and write the prime factorization. It's going to be 2 times 2 times 3 times 5. So let's see, our complete factor list is going to start with 1 and 60. Do we see a 2? I see a 2 right here. 2 times 3 is 6. 6 times 5 is 30. So hopefully that makes sense. 2 times 30 is 60. What about 3? I see a 3 right here. That means that this 2 times 2 is 4. And that 4 times this 5 over here is going to be 20. Hopefully we know 3 times 20 gets you 60. 3 times 20. Is there a 4? Sure, 2 and 2 make 4, and that means this 3 and 5 make 15. That makes 4 and 15 factors of 60. Is there a 5? Yeah, we see a 5 right here. 2 times 2 is 4, times 3 is 12, so 5 times 12 gets you 60. Is there a 6? I think so, because 2 times 3 does get you 6, and then 2 times 5 gets you 10. So you can see here that means that 6 times 10 is going to be 60. Now the numbers between 6 and 10 are 7, 8, and 9. There's no 7, there's no 8 because you need an extra 2, and you need another 3 to have a 9, so we don't have that either. So 60 here is going to have these 12 factors. For number 11, we have the number 45. Let's go ahead and break that one down. Let's see, I'm going to start with 9 times 5, right? And 5 here is prime, so that one stops. But this 9 can keep on going. It's going to break into 3 times 3. All right, cool. So here are our prime numbers here. And so our prime factorization, it's not too long here, right? It's just going to be 3 times 3 times 5. All right, awesome. So let's take this 45 and write our factor list. Start with 1 and 45. Is there a 2 on the list? I don't see a 2, so we'll skip that one, go to 3. Here's a 3. 3 times what? Well, 3 times 5 is 15, so 3 times 15. What about 4? No 4. What about 5? I see a 5 here. And then 3 times 3 is 9, so it's going to be 5 times 9. 6, no 6, 7, no 7, no 8 either. So 45 here has 6 factors. We have them all. All right, for number 12, we have the number 72. So let's take this 72 and then break that down. That's going to be, I'm going to start with maybe 6 times 12. Okay. For 6, I'm going to break that into 3 times 2. And for 12, I'm going to break that into 2 times 6. And then the 6, I'm going to break into 3 times 2. So here are our primes. We have a 3, 2, 2, a 3, and a 2. All right, so for 72 here, we're gonna say the prime factorization, where you have, looks like 3 of these 2's multiplied together, and then 2 of these 3's multiplied together. So what's our factor list? Well, let's start with 72 and just write 1 and 72. We see a 2 on the list here, so that's 2. 2 times 2 is 4, 3 times 3 is 9, 4 times this 9 is 36. So we know 2 multiplied by 36. Let's see, do we see a 3? Well, yeah, here's a 3. Let's see here, 2 times 3 is 6, 2 times 2 is 4, so 6 times 4 is 24. So 3 times 24 is also 72. What about 4? These two 2's make 4, and 4 times what is 72? Well, 2 times 3 is 6, and 6 times 3 is 18, which means 4 times 18 is going to be 72. Is there a 5? Nope. Is there a 6? Yes. 2 and 3 make 6, which means that this 3 times this 2 is 6. 6 times this 2 is 12. So that means 6 times 12 is going to be 72. What about 7? Nope. What about 8? I do see an 8 because 2 times 2 is 4 times 2, that's 8. And then 3 times 3 is 9. So that means 8 times 9 is 72. So 72 here is going to have these 12 factors. All right, here is number 13. For number 13, we have the number 57. Now this one's pretty interesting. It looks like it could be prime, but if you use your divisibility rules, 5 plus 7 is 12, which means the sum of the digits is a multiple of 3, which means you can divide this by 3. So that means 3 times something is 57, and so that's going to be 19. Okay. You can also think about how 3 times 20 is 60, but if you take away one of those 3's, it's going to be 57. So very short prime factorization here. It's just going to be the product of these two primes of 3 times 19. That means that our factor list is going to be rather short, which is kind of nice. So for 57, we just have 1 and 57. And that's it. We also just have this 3 times 19. So it's kind of nice when you just have those two primes because the factor list is very short. Here is number 14. For number 14, we have the number 135. Let's take this 135. Let's see, use your divisibility rules here. I think we can divide this by 5, right? And 5 times what is 135? I believe it's going to be 27. Okay. And then this 5 is prime. So let's go ahead and circle that. If you need to do long division on the side, feel free to do so. For 27, I'm thinking 3 times 9. And this 3 is going to be prime. And this 9 is going to break down into the product of 3 and 3. Alrighty, so it looks like we have all our primes now. So for 135, we're going to say that's equal to 3 times 3 times 3 times 5. Alright, so let's see our factor list. We're going to start with 1 times 135. Is there a 2? No, there's no 2. What about 3? Here's a 3. What 3 times what? Well, 3 times 3 is 9, and 9 times 5 is 45. So that means 3 times 45 is going to be 135. There's no 4. We need even numbers to make 4. Is there a 5? Yes, there's a 5 here. 5 times what? Well, 3 times 3 is 9 times 3 is 27. So we can say 5 times 27, but hopefully that makes sense because we already did that in our tree. There's no 6, there's no 7, there's no 8, there's a 9, because 3 times 3 is 9, and 3 times 5 is 15. So that means we know 9 times 15 is going to be 135. Between 9 and 15, there's 10, doesn't work. 11 would be on the list, but it's not. 12, you need a 2. 13 is prime. 14, you need a 7 and a 2. And 15, we already took care of. So that's all the factors for 135. For number 15, we have the number 96. Let's go ahead and break 96 down. I'm going to start with maybe 2 times 48 here. Again, you don't have to start with the same exact factors, but I'm going to choose that. For 48, I'm going to do 2 times 24. My 2 over here is prime again, and I still have an even number, which means we can keep using 2's. I'm going to just keep rolling with the 2's here. 2 times 12, and this 12 is going to break into 2 times 6. This 2 again is another prime. And finally, the 6 I think is going to stop with a 3 and a 2. So this is a little bit bigger of a tree here. What's our prime factorization? I'm just going to write it out and say, I believe we have 1, 2, 3, 4, 5, 1, 2, 2 2's, 3 2's, 4 2's, 5 2's, and then a 3. All right, so it's a pretty long prime factorization here. You can use exponents to write it, but I think it's easier to keep it written out expanded like this to help with the factor lists. So I'm going to start with 1 and 96, as we always should. And then we have a 2 here. 2 times what is 96? Well, if you multiply 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. Or you can see here, I already said here that 2 times 48 would be 96. And what about 3? Here's a 3 here. So 3 times what is 96? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we're going to say it's going to be 3 times 32. What about 4? Well, 2 times 2 is 4. So 4 times what is 96? Let's see. 2 times 2 is 4. 2 times 3 is 6. 4 times 6 is 24. So 4 multiplied by 24 is 96. There's no way to get 5. It's prime. It would be there. But 6 is definitely here. So 2 and 3 make 6. So let's see. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So I mean 6 times 16 is going to get you 96. There's no 7, that's prime. 8, I think we have an 8 here because 2 times 2 is 4, times 2 is 8. So there's 8, and then 2 times 2 is 4, times 3 is 12. So 8 times 12. That's going to get you that 96. What about 9? A 9 would require 2 3s, but we only have 1. 10 needs a 5. We don't have a 5. 11 is prime, and I think that takes care of it. These are all the factors for 96. Finally, for number 16, we have this number of 144. So let's go ahead and see if we can make this 144 break down into its prime factorization and get all the factors. So I think a common thing to choose for 144 to start with is maybe this 12 times 12. Okay. If not, you can just divide it by 2 to start with because it's an even number. 12 is going to break into 6 times 2. And also we can say that this 12 is going to break into 6 times 2 or 2 times 6. These 2's are prime, so those are going to stop where they are. And then these 6 are going to keep breaking down. The 6 we can say is going to be 3 times 2. I'm going to go ahead and circle these prime factors. And then this 6 over here we can also break into 3 times 2. Alrighty, cool. So let's go ahead and write the prime factorization out here. For 144, we had a lot of matching things here. So it looks like we have 4 of these 2s. So 1, 2, 3, and 4. And then we have 2 3s. So we have a 3 and a 3. So let's talk about the factor list now. So 144, let's start with 1 times 144. Do we see a 2 on the list? Here's 2. 2 times what is 144? Well, 2 times 2 is 4. 4 times 2 is 8. And then 3 times 3 is 9. So what's 8 times 9? That's 72. So that means we have 2 multiplied by 72. That's going to be 144. Is there a 3? I do see a 3 over here. So here's 3. 3 times what is 144? Well, let's see, 2 times 2 is 4, 4 times 2 we said was 8, this 2 times 3 is 6, and 8 times 6 is going to be 48. So that means 3 times 48 must be 144. So 3 times 48. What about 4? I can get 4 with these 2 2s, so that's 4. And then 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is going to be 36. So we're going to get 4, and then we're going to have 36. So we have 4 times 36. Is there a 5? I don't think so. Is there a 6? Yes. So here is 2 times 3, which is 6. And then 6 times what is 144? Well, 2 times 2 is 4, times 2 is 8, times 3 is 24. So we have 6 multiplied by 24. 6 times 24. 7 doesn't make the list. 8 will make the list here. 2 times 2 is 4, times 2 is 8, so here's 8. And then 2 times 3 is 6, 6 times 3 is 18. So we're going to have 8 times this 18 here. 8 times 18 is going to be 144. All right, let's see if we have a 9. 3 times 3 does get you 9. And so 9 times what? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So we now know that 9 times 16 is 144. Now let's see, there's no 10 because we would need a 5. 11 is prime. 12, I think we can do 12, right? A 12 is going to come from a 2 times 2 times 3. That's 12. And then we're left with a 2 times 2 times 3, which makes sense because 12 times 12 is 144. So these are going to be the last pair. But remember that this is actually redundant, so we're going to ignore one of these. So if we look at how many factors 144 has, it's going to be 2, 4, 6, 8, 10, 12, 14, and then we have this 15th factor because it happens to be a perfect square, so it has an odd number of factors. All right, so there you have 16 different practice problems on writing complete factor lists for different numbers. The factor trees hopefully are helpful, and then try to use that prime factorization to help you get all those factors down for each of these numbers. If you found the video helpful, please consider sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.